Hello, this is my video explanation about the exam of machine learning. So here is the original data. And so first, we have to examine the data set for errors, the missing values. I labeled them here. Red is for the missing value. String error is for yellow, and for outlier, we don't have anything. And over here, we just use formulas in sheets to get the min-max values, the mean, the median, standard deviation, quartile 1 and 3, IRQ, upper bound, lower bound. And then after that, we count the amount of string in these columns here into here. And then we get to data cleansing, where we fix the table. And I decided to fill in the missing integers with the median because it's way cleaner to look at, and also correct the string errors here, as you can see. And then we recounted the amount of string here and the total of it. And then next is we did a min-max normalization here of from this table, and we also made a new table of the mean, median, max, standard deviation, Q1, Q3, IRQ, and the upper and lower bound based off of this table up here. And now we move to feature selection. So from the original table up at data cleansing, we again change the data input into 0, 1, and 2 depending on the amount there is. So for trait type, there is only 3 of them, so 0, 1, and 2. For destination country, there is 15 of them, so 0 to 14. Transport mode, there is 3 of them, so 0 to 2. Same thing with trade risk, and for trade category, there is 4 of them. So all of them are listed here on the left side of the sheet. And now after this, we do the min-max normalization again. And over here on the right side is the z-standardization. And after this, we had to minus it with the mean, this table minus with the mean, and we get the new table here of the min-max. And on the right side, you do the same thing, except this one is for the z-score. And then after that, we get the mean. It should be equal to 0, both. And then we also get the standard deviation in order to do the covariance. And our n, it will be 15 since we have 15 inputs. And over here, after getting the covariance through multiplication of the amount of columns we have, we do the correlation. So we get the values and we set the condition. And as for me, I set my own condition first, but I also followed the condition as well of what was listed in the lecture. So if I was able to set a condition here, it would be if the absolute correlation is more than 0.7, then my first choice was either remove the highest pair, or just remove all of it. Then only one feature will remain, since this has a decent enough correlation. It's the most viable one. Or if we follow the lecture, if absolute correlation is more than 0.5, then there will be no features in this data because they exceed 0.5. Now, for the z-score, however, there is one score, which is the oil price and shipment, that has a decent enough correlation that we could use that feature. So again, this is my own condition. If we follow the 0.7 greater than, then there will be 2 features, which is oil price and shipment and total trade and shipping. But if it's according to the lecture, then there's only one feature that remains, which is the oil price and shipment. Now, next, let's move to the MLP. So again, we get the normal table from the data set. And over here, we use the min-max values that we got from data cleansing and feature selection to do the calculations in order to predict the model, the accuracy, using the given weights and bias that was given to us here. So pretty much we did min-max according to the last table, and then here we calculated for the z-score which is pretty much total trade for me, times theta 1, which is up here, plus shipment volume times theta 2 of node 1, and then plus theta 0. So we did that. And for node 2, it's the same thing, but we use a different theta value here, which is for node 2. For node 3, it's the same thing. We use this theta values here for node 3. And now I decided to choose sigmoid here. This is the formula. And just to calculate using sigmoid. And then after that, we go here. This is the output, or sorry, this is the value of output 1. This one is for output 2 and 3, which is layer 1 node 1, layer 2 layer 1 node 2, and layer 1 node 3. And then after that, we pretty much multiply these values here that we got after sigmoid with the theta value of the layer output. And then after that, we get the min and max from this values we calculated. Oops. From the values we calculated. And then we had to set a range so that we can get the Y prediction here. So as you can see, I set a condition for 0. If the value of this is 0 until 0.009, then it will be 0, such as this 0 here. But this value here is 2 because it is between 0.34 until 0.66. And I did the same thing for the whole column here into this. And then we get Y real from the given table. And then we calculate the error, which is we minus Y real minus the prediction, and then error squared, and then calculate for the MSE, or the average of this. So that is my MLP for this exam. And then also next is the model evaluation. So here we pretty much will only take note of Y real, or the model category, or trade category, sorry. And over here I listed the assignments and the amount. And here we predict pretty much using first the prediction Y1 into here with the actual Y. And through that, we get the Y prediction by adding the columns. And we get the Y real by adding the rows here. And then we get the recall by dividing this corner here with Y real, and also this pretty much this kind of slanted line here with Y real. And then we get the value of the recall over here. And then for precision now, it's by the same thing, but it's vertical, and we can calculate the accuracy by getting the sum, or adding up this thing here, this slanted line, and we get the sum of the whole table, which is the accuracy, which will be the accuracy of model 1. And now for model 2, it's the same exact thing, but using the prediction Y2, and same process again with the accuracy. You can observe here that model 2 is more accurate for me compared to model 1, and it pretty much outperforms model 1 in terms of accuracy, recall, and precision. Model 1 has 25% accuracy, while 2 has 36.36, which means that model 2 makes more correct predictions. And the recall measures how well the model captures actual positives, and model 1 struggles with that. But model 2, on the other hand, has recall values, so it identifies more. That's why it's slightly better than model 1. And then here is the other questions of the exam about business interpretation and decision making. Pretty much discuss about why it's higher accuracy and whatnot, and what to get, what to lose. Pretty much for model 2, we are getting more predictions, more correct ones, leading to better decision making, more actual positives, reduced risks of false negatives or missing cases. And it's very beneficial or in applications where missing a true positive, such as fraud detection or medical diagnosis, has serious consequences. And there's better precision, as I said. And what we lose with Model 2, though, there is more false positives in certain cases, and it's also still not perfect. So there's weaknesses, and there's a potential complexity, more computational resources, or longer training time. It might not be ideal for real-time application. So yeah, the choice between the two depends on business priorities. If missing true positives is costly, Model 2 is better. But if false positives lead to significant resource waste, then yeah, there might be a need to optimize precision on Model 2. And now, provide a business-oriented interpretation of models' predictions and how they impact decision making. The performance of predictive models plays a very big crucial role. Since Model 2 has a higher accuracy, it would be the better choice for practical use, but accuracy alone is not high enough or is not enough. Recall and precision must also be considered. So yeah, I've listed a couple of examples here in predicting customer churn. Fewer at-risk customers are overlooked. This enables the company to proactively engage with them before they leave. But if false positives increase, the business might spend unnecessary resources on customers who are not actually at risk. So yeah, there's example in fraud detection, risk management, operational efficiency, and cost management. But overall, Model 2 provides a stronger foundation for decision making, but yeah, there needs to be further refinement to ensure its predictions align with business goals and minimize financial risks. Thank you.